set for myself. So if I want to accept every PT, every active PT market on Pendle, I can go ahead and set that for myself. So, if I want to accept, I think on mainnet right now, on Pendle, there are 73 active PT markets. Now, many of them are quite illiquid. I could, if I wanted to, build a portfolio, a vault that contains exposure to all 73 of those PT active markets on mainnet right now. And then I can also set my interest rate module. So my interest rate module could be floating if I wanted it to be. I don't know why I would want that, but maybe there's a reason why I would want that. Or I can set it to fixed. So I can borrow against assets in this PCF at a fixed rate. And so I set that fixed rate to 25 basis points. So just think about how powerful that is for a second. You can deposit any collateral that you set. Okay, so you could deposit anything you want. If you want to deposit gold, go ahead. If you want to deposit tokenized silver, you got it. Or if you want to build a structured crypto bond ladder, you can do that too by allowing PTs to be deposited as collateral. And then you can borrow at a fixed rate against that PT collateral. And you can set all of the LTVs and LLTVs for each individual piece of collateral. So that basically allows you to set the leverage ratios for each individual piece of collateral within this vault. And remember, you do this all for yourself. So when it comes to security, the keys here, that's just one piece. There are no guardrails. Like if you mess up, building this, there's no one that's going to come and save you. So this is really the Wild West when it comes to financial engineering. But man, this is phenomenally powerful. I've got a proprietary strategy that I'm not prepared yet to share publicly, but if I'm able to implement it over the weekend, I might share it next week. So yeah, it's pretty mind-blowing.
Before anything touches mainnet, you need a serious pre-flight check. This is absolutely critical for a safe launch. What's really cool is how simple the setup is. You just define all the key parameters right here.
Okay, so it's actually really, really simple. There are like 7 smart contracts. I've already written them all. And then it's just a matter of a deployer wallet, a governance wallet, that's the multi-sig wallet, and then making sure that you've got the RPC URL, which is a piece of cake. You get that from Etherscan for free, or you can use Alchemy. So those are websites. You can go take a look at those. So you have your deployer wallet, right? And so you've got your private key for your deployer wallet. And that is going to sign these smart contracts in a specific order as you deploy them. And then once it's done deploying the contracts, then you assign governance. You transfer ownership to the governance wallet, which is just a multi-sig on Safe. And if you guys haven't seen Safe yet, you got to take a look at Safe. I'll share that with you in a couple of minutes here. But you deploy using your deployer wallet, and then you once you've deployed, you transfer governance, you transfer ownership to the governance wallet, which is a multi-sig. So that's going to become the governor. And that can be signed by multiple individuals.
These 3 stages, unit, fork, and dry run, basically test everything in a simulation before you even touch mainnet. Okay, checks are complete. Time for the mainnet launch. This is a very precise multi-step operation. This whole process covers everything, from deploying contracts all the way to setting up the final collateral assets.
Okay, so check it out. It's actually quite a bit more simple than you might think. Once you've got all the contracts written, then you begin by deploying them using that deployer wallet. And once you've done that, it's all signed and deployed, you transfer ownership to the multi-sig wallet. The multi-sig becomes the governor by accepting and confirming its new role. And then you initialize the Oracle feeds, and then you configure the PT collateral. So it's actually quite a bit more simple than you might think. And once you've actually deployed the vault itself, then it just comes down to structuring the portfolio and determining, okay, well, LTVs and LLTVs do I want for each individual piece of collateral? Because that's going to determine how much you can borrow against them. And remember, we're going to be running just the cheat loops, borrowing against these things. So it's simple. It's simple. That's right. Super simple.
Here's a fun fact. After you set up the price oracles, you have to wait over 30 minutes. So
So
why
you have to wait 30 minutes because you need to get some price data.
the long pause? What's the deal with this mandatory delay? Well, it's actually super important. It's all about security. This wait stops price manipulation by letting the oracle gather enough stable historical data. And now for a huge moment in decentralization, the official handover of power. This part is key. This two-step process is vital. It makes sure control is passed over intentionally and securely to the multisig.
Right. And so this is actually very straightforward. So you have your deployer wallet, which deploys all of the contracts, signs them, and then it goes ahead and transfers ownership to the governor, which is the multisig wallet on Safe.
The system's live, but we're not done yet. There's one last post-launch checklist to run through. This final check confirms that everything is secure, public, and works exactly the way it's supposed to. So the launch is perfect, but it leaves you with one big question about who really holds the power.
Yeah, who watches the watchers? So who's got governance control? You know, you ever think about that? I never really thought about that until I started trying to build this stuff. For all of the protocols that we use, someone somewhere, owns those keys and controls those keys. Someone somewhere has governance. So take a look at Safe. This is, I'm not going to sign in here, but this is really, really cool, man. So you guys remember when I think it was Bybit, the CEO of Bybit was transferring like $1.5 billion of wrapped staked ETH. And he made a mistake in not verifying the URL. And it looks like a North Korean hacker was able to somehow inject a URL into the process when he was signing in order to siphon that ETH. And it was a big amount of ETH. So that was a very, very famous exploit here on Safe Wallet. Yeah, this is what it looks like. And so this will become the governor for that Euler PCF after I use the deployer wallet to deploy all of the smart contracts. And so now we can take a look, now that we know just a little bit more about this, we can go ahead and take a look. Let me go ahead and clear that. I've been having a difficult time with YouTube getting ads launched, but if we just take a look at this Euler PCF, so it's a whitelist-based private credit facility with a fixed borrow rate. So I'm going to run 25 basis points. I'm going to use Pendle PTs as the accepted collateral. Transfer all of the contracts here. Here's the pre-deployment. Just validate everything looks good. I can run through, I've got all of these items all ready to go, the private key, the mainnet RPC, the governor multisig, the fixed rate APY and basis points, and the Etherscan API key. So I've got all of these data here. And then I've just got to use Forge to run those tests, which I've already got the Forge SDK. I've got it all installed. So I can just run this and Cursor does this for me. And then Cursor is going to run a dry run using Forge. And then I can just check governance. And okay, so what is this? Governance and rate consistency. And then here's the deployment sequence. All right, so super high level flow here. But what I'm going to do is I'm going to have it give me a little bit more of a detailed step-by-step view of the deployer sequence. So it looks like deploy full system. So router, oracles, vault, hook, interest rate module, and PT adapter. So those are the contracts: the router contract, the oracles contract, the vault contract, the hook contract, the interest rate module, and the PT adapter. So 1, 2, 3, 4, 5, 6. 6 contracts. I think there might be a seventh actually. So I'm pretty sure it's 7. So this is pretty much all automated, man. Like I don't really need to, I think it just uses Forge to do this. And it's already written the script and all the contracts are already written. So as long as the contracts work, then I should be able to deploy this. And then it's just a matter of figuring out how many single lines of code there are in those 7 contracts, because that will give me like a ballpark idea of how much it'll cost to get them audited. So the audit works based off of single lines of code. So if I've got 7 contracts and 300 lines each, that's 2,100 single lines of code. So we'll see. We'll see how many lines of code it is. But yeah, this is pretty cool. So I'm gonna run this over the weekend, and we'll see if it ends up with a Euler PCF by Monday.